Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to discussing about the face marks classifications using deep learning. And also we are building one web application at the last of the video. Here you can upload an image and try to classify that if the person is hiring marks or not. So बिना किसी डर के हर हर महादेव बल के start करते tutorial. Alright, so in order to building the face mark classification project, you're going to use the dataset from the Kaggle that's called a face marks detection dataset. If I go down and you can see it having a folder called data, and inside this folder it having two folder that's called with marks and without marks. So each of the folder having the images of the marks and without marks. Now using this data set, we are trying to process our images and try to building one deep learning model so that we can classify the images of the face marks and face without marks. Well, so you can see here I download the dataset for the Kaggle, and also you can see here a folder called data and also one empty IPNB file. Okay, so that's our data set. If I see inside my folder directory, you can see here this the data folder, and inside this folder it have two folder called with marks and without marks. So that's the images with having the marks. If I go inside the without marks, it's having the picture without marks. Okay, that's the data set how it looks like. Okay, now if I go inside my Jupyter notebook, and also you can see here I having one empty IPNB file, and here you could try to do the coding part. So for this case, you're going to using here the Jupyter notebook. You can actually using here the Google Colab or PyCharm itself. Well, so it's time to do the coding part here. So first thing first, I'm going to importing here all of the important library. So first I'm going to importing here the OS. So let's say import OS. So OS is also called the operating system library. Using that, you can creating the list of the images. I mean, you can getting the data, I mean, the images from your folder. So if I see the data, just to white, and you can see this our data set inside my data folder, and inside this folder it having the images of with marks, and you can see images of the with marks. And if I see the without marks, that's the images without marks. So now what I can do using the OS library, we can creating one list of the images. Then we can simply going to using here one for loop or forest loop in order to iterate to all the images name from the directory. Then I'm going to importing here the numpy library. So let's say import numpy as np. So using numpy, we can convert these images in the from other numpy array so that we can pass it inside our convolutional neural network or the deep learning network. Well, then I'm going to importing here the matplotlib, matplotlib.pyplot, so that I can show my plot in my, I mean, visualization in my Jupyter notebook. Okay, then I'm going to importing here the import matplotlib.image as mp image. So using that, I can load the images from a directory and I can show it in my Jupyter notebook. Then I'm going to importing here the CB2, that's also called the OpenCV. Using OpenCV, you can do the image processing, just like the resizing your images or converting your images into the BGR to RGB or BGR to the grayscale images. All kind of tasks you can do it using the OpenCV library. Then also I'm going to importing here the PILU library. So from PIL, I'm going to importing here the image. So using PILU, it's also on computer vision types of machine learning library. Using that, you can do some operation on the images. Then after that, I'm going to importing here the train, test, and split. Say how you're building any machine learning or deep learning model, you need to divide your data set into train and the testing. 80% for the training and 20% for the testing. See, we just having what data, we just having the two folder with marks and without marks. This data set is not divided in the train and the testing or validations. So what can do, we simply going to divide it. We can simply going to divide it with our own code. Well, so for that, I need to import it. Let's say from sklearn. So let's sklearn dot model selection. I'm going to importing here the train test split. Okay, I just go slowly so that if you are a beginner, you can understand it easily. Well, see, we got some error. No model name called matplotlib. और थोड़ा mistake होगा यहाँ पर. Matplotlib, fine. Well, you can see all of the images, all of the libraries actually imported, and also you can see just one kind of warning. How I'm actually running this code for the first time, I can got some warning. So I can also ignore the warning. So for that, I can importing here the warnings. So let's say warnings, warnings. Then after that, I can simply going to filter the warnings. Let's say warnings dot filter or warnings. Okay, warnings. And after that, I can simply going to ignore it. Okay, because I'm going to using here this Python 3.8 library. So some of the library should be the deprecated, okay, just because of older version of Python. Yes, you can also using here the newer version of Python, just like Python 3.12 is also is launched in the market. So you can also install in this library, okay. But Python 3.8.5 is suitable for me. Well, now what I can do is simply going to load the data from our folder. So for that, we can using this os dot listed. So listed is nothing but creating the list of the all of the images. All the images not mean actually all of the files should be inside your folder. In folder, which one if you mentioned it in your parenthesis. Let's say we have the images inside my data folder and with marks, with marks. So it will creating one list of that. If I using the shift enter, and you can see it creating the list of that images, list of the images. So let's assign it to variable called with marks. That's the files. Yeah. So see, with marks file is loaded. So now what I can do is simply going to do the same thing for without marks. So let's say without marks. So let's make it without marks, without marks. So with marks and without marks file is loaded. So what I can do if I try to loading these images, if I try to loading these images, so what I can do, I simply going to creating one for loop and try to iterate to value all the value from here. Why? Because this is one list. If I try to check in this one, that's a type of this with marks file. See, this is nothing but one list. So from the list or the array, we can iterate to value from here using for each loop or the for loop. Yeah, this is how you can load in the images. Then you can simply going to pass it inside this OpenCV or this PLU library. Well, now if I try to checking the image name, let's say I'm trying to going to printing it out. Let's say print, let's say with marks file. Okay, just going to printing here first 10 and name, and you can see, yeah, marks files is not defined. Yeah, now you can see the first 10 files is appeared for the with marks, and you can also do the same thing for without marks also. Just copy this out and paste it here, and you can see. You can also see that how many number of images should be in each of the folders. So what I can do, you can simply going to using here one print statement, so that you can also run in this code in your PyCharm also. Yeah. So let's say number, okay, number of with marks images. So we can using here the length of that. So let's say length of the with marks file. Let's say with marks files. Yeah, you can see here with number of with marks file is nothing but 3725 of the images are available inside my folder. So let's taking this one and going to copy this one, and let's say this is for without marks. So without marks, and I'm simply going to convert them to the without marks. Yeah, this is the images with the without marks images. So let's try to do the total of that. So let's say print total number of images, total number of images. Okay, total number of images. Okay, so let's see. Let's using the length of the with marks file, and after that I can join it using plus sign, the length of the without marks file. Just going to copy this out and paste it here, and here you go. And you can see 3552 are total number of images, and number of marks images is nothing but 3725, and 38275 for without marks. Cool. Now what I can do is simply going to do the label encoder. Do the label encoder. Why? See this marks and without marks in the from the string. Just mean this is nothing but one string file names. So if you're trying to building in a deep learning model, you have to pass the data just like the 0, 1, 2, 3, 4, 5. If you have the 6 classes, see this is the binary classification task. That's been 2 classes. That's been 0 and 1. So you need to assign one of the value with the 0 and one of the value with the 1. So what I can do is simply going to value, assign the value for the with marks should be the 1. Okay, if the value of the output is coming as a 1, it means the with marks. Otherwise, we can making the without marks should be the 0. Just going to creating a label for that. See, we having the list of the images. We have the list of the images. So what I can do, let's say I have 4 images. I have 4 images. So I have 2 images for face marks, Okay, and I have two images for face without marks. Okay, face without marks. Well, so what I can do, I simply going to creating here one list of that. Okay, just creating a list. So face marks dot, let's say this is called JPG or JPEG, or this is also JPG. So when you reading these images using this OpenCV library or the PLU library, so we can also convert the images into from the numpy array, in the form of the numpy array. So let's say this is the face marks images. So face marks means the data should be given as a one if it having just one images. Now it have two images, that's in 1 comma 1. It's also going to using the path of that, let's say two images. Okay, two images. So these levels of the images path should be like that. So what should be like that, what should be for that? So this should be also two images, two images, and the list is nothing but 0 comma 0. That's mean this is the label for this one, this is the label for this one. This is how label is created. Okay, now this face marks.jpg, this face marks.jpg is converted into the numpy array, into the numpy array. That's mean this will look like that. Let's say this is a numpy array, let's say 0 0.5 comma 0 0.5 0 0.7, or let's say 0.8 or dot 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 dot, and with having one label with the one. That's mean this is the image for the face marks. So now there's the basic things. We're simply going to do the coding part here. I mean, going to make it. Okay. So let comment of those lines, because this is really important. This is really important. So what I can do is simply going to creating the list of the ones with having the marks, and for 0 for without marks. Well, now let's take in one shell, and now let's say with marks label, with marks labels. So with having all of the images of the one into how many images we have, 3 7 to 5. Then let's do the same thing for without marks level also. So this is called the without marks level, without marks levels. Okay, let's make it 0, and also going to convert them into 3 8 2 7. Yeah, now we're creating here the list, I mean list of the labels for the with marks level and without marks level. Cool. Now we can also checking the length of that. If you have any doubt about that is really created or not, so you can check in the length of that. Yeah, length is correct. Now you can copy this one also and try to check in the length of that. Yeah, that's fine. Now what I can do, we're simply going to joining all of them. We're simply going to joining all of them. Okay, for joining we can let's creating a variable called levels, and we're simply going to joining this one without marks level and with marks level and without marks level. Okay, okay, this is the levels. Now levels is created. If I try to checking this one, so one is created. Let's say let's taking for the last one. Yeah, 0. Let's say first two. Yeah, 0. Okay, fine. Now that's mean this is created. This is created. The label is created. It having total number of length is nothing but 37552. If I try into checking the length of that, so length of the labels is 7552. That's mean we're creating one labels for that. Now what I can do is simply going to taking one images and set it, and taking one label from the label folder, I mean label list, then join them and creating one data set, just like the CSV file, with having one dependent feature with having an independent feature. This is how you can actually do the processing, right? Now our processing past, I mean first number part is done. Now the second part is nothing but convert the images, convert the images and resizing the images. But before that, let's try to display some images. So for that we can using here the mp images. Let's say mp image dot imread, and inside that we can giving here the path. So let's say first show the images with marks, with face marks. So let's say with marks, and now let's taking one image name from here. Let's taking this one with the JPEG. Okay, with the JPEG, just copy this one, and I'm simply going to pass it here. Yeah, here is it. Yeah, fine. Okay, that's it. Yeah, fine. Now let us assign it a variable called image. Well, this is the images of with marks. Okay, then I'm simply going to using here the plt.imshoe, we already imported, and inside that I'm simply going to passing here my images, and let's try to put it inside and plot. So that's img plot. Okay, and now I'm simply going to show it. That's plt dot show, and inside this show, I don't need to pass it here because this is nothing but for showing this plt graph, I mean plt visualizations in your Jupyter notebook. Okay, so let's use it. Yeah, this is how images look like. So let's try to display the images for without marks. Okay, without marks. So let's taking one images from here. So let's taking this one, and I'm going to pass it here. Yeah, let's say this is for without marks. Yeah, थोड़ा गड़बड़ हुआ है. Opa. Yeah, here you go. Yeah, now it's fine. It's look angry. Okay, the image looks angry. Okay, this is the images for without marks, and this is for the with marks. Cool. Now we can load all of the images from my directory folder. Just creating one list. Now what I can do is simply going to iterate to all the below from here. So for that I can using here this with marks file. So let's say this is called let's say convert image into numpy array. Okay, numpy array plus resize plus convert them into the RGB. That's RGB. Fine. Okay. Well, so now what I can do is simply going to iterate to all the below from here. Let's say for image file from in with marks file. So what I can do, we can taking all the images. So if I try to painting it here, let's say print the image file. Yeah, you can see all of the image file it here with marks 1, with marks 10, with marks 100, all of the images getting it here. But you need to also add it with my absolute path of the images, I mean my actual path, this path, so that we can getting the actual images. So for that what I can do, we're simply going to creating here one path of that. Let's say with marks path. Okay, so we can taking the path of that. Let's say this is my path. Let's say from the data we have in the with marks. Okay, this is my path. So now I can read in the images. So what I can do, if I trying to copy this one, and if I trying to pass it here and join it, and now you can see we can got here our absolute path data with marks with marks 1001.jpg file. Now we can simply going to load the images. So you can load the images using the OpenCV library, using CB2 library. Otherwise you can also using here the Pillow library also. Okay, that's your choice to do that. Yeah, let's try to do this using the Pillow library, and your job is to do it using the OpenCV library. Okay, let's say image dot open, and inside that I'm going to giving here my with marks file path. Okay, with marks path plus plus the image file. Okay, well, now let us assign the variable called image. Okay, image equal to, then what I can do, we can using here resize. So let's say image dot resize. Okay, well, let's using one tuple. Let's say 128 comma 128, and let's assign the same variable called image. Okay, fine. Okay, image. Okay, our resizing is done right now. Now our task is to do the convert in the RGB. Convert in the RGB. So let's say image equal to image dot convert. Okay, convert. Okay, convert in the RGB. Okay, in the RGB. Then your task to do the same thing for the OpenCV also. Now our task is to do convert them into the numpy array. Let's say np.array, and inside that I can pass in here my images. Now let us store this data inside one data list, so that we can join it with our levels file. Okay, so let's say data.append, and inside I'm simply going to pass in here my images. Okay, if you're using here the OpenCV, so what should be code like that? So let's comment out here. Let's say cb2.imread. Okay, cb2.imread, and inside that I can pass in here this one. Let's say image marks file path and image file. Okay, Okay, you need to pass it here, and for this ones the resizing should be the cb2 dot resize, and inside that you're giving here 128 comma 1, but before that into passing here your images, and you're giving here the width and the height, that's 128 comma 128. And for this one you can using here cb2 dot cbt color. Okay, cbt color. There should be the cbt color. Actually my electricity is gone, that's why. So let's say image, and you're giving here the color bgr to rgb, like that. Okay, okay, color bgr to rgb. So this is how you can actually convert them. Okay, so this is a code for the OpenCV, and this is the code for the PILU library. Okay, so let's shift enter. Yeah, it's loaded and it will take time. Let's do the same thing for without marks. Okay, let's do the same thing for without marks. So what I can do, we can do the same thing for without marks. So let's make it without marks, and I can remove this data because we also already have the data list. So you can simply go to passing the same things here. So with marks file should be the without marks file, and see all the things are okay. So it should be the without marks file path, without marks path. Okay, without marks path. Yeah, that's fine. Without marks path, without marks path, without marks path. Yeah, this should be the without marks path. Yeah, just copy this one. And also, yeah, there should be also changes without marks path. And resizing is okay, convert is okay, numpy is okay, and also the data dot append. Yeah, fine. And let's try to do the same thing here. Okay. Yeah, it's taking time. Yeah, I will back after right after when the execution is completed. Okay, so our execution is completed, and it will take 5 to 10 minutes for executions, because it's just having the 7,552 images, so that's why it'll take time. And also resizing the images and also convert them into the RGB format, so that's why. So let's taking the length of that. So let's say length of the data. Yeah, you can see here 7,552. And let's try to checking this type of that. Let's say type of the data is nothing but list. Yeah, because yeah, you already initializing here on empty list, just it will put here the value of that. So if I try to checking the data, just checking the data, let's take in the first index. You can see this is one numpy array, this is one numpy array, right, numpy array, with having all of the images in the form of UINT8, unsigned integer 8 bit. Okay, I mean it converted these images into the numpy array. Now what I can do now, we're simply going to we're simply going to converting this data into in the form of the x and y, I mean the dependent and the independent features, just having adding with the data and adding with the levels, right? You can also check in the shape of that. Let's set data of 0 dot shape. Yeah, you can see here 128 128 3. That's mean number of row, or you can say width of the images. Height of the images is 128, and 3 means number of channels. I mean this is an RGB images. Cool. Now we're simply going to divide our data set into dependent and independent features. So for the x, the in the x the data should be go for the data, and for the y it should be the levels. Okay, so let's say x equal to np.array. So let's say equal to np.array, and inside that we're simply going to passing him a data. Okay, that's my problem with the keyboard. So let's say data, and for the y we're simply going to passing here the levels. So let's say np.array, and simply going to passing the levels. So this is nothing but converting your list and the levels into the numpy array, and after that divided the data into dependent and the independent features. Cool. So x and y. Now what you can do, we simply going to using here the train, test, and split, and after that we can simply using here deep learning model, just like CNN, to extract the feature from that. Well, so you can also printing here the x. So let's say x. So this is the x. Okay, you can also checking the x of 0 dot shape. Okay, shape, just shape. Yeah, this is the same shape as it is, you can see. If I try to checking for the y, Yeah, y don't have any shape actually. It's just having the y one shape with the labels. If I try to checking for the y, and this is the for the y. Yeah, now we're simply going to using here the train, test, and split in order to divide our data set for the training and the testing. Okay, so now what I can do is simply going to pass it here, and we're simply going to passing here the x. Okay, x. Okay, shift x comma y. Then after that is simply going to be using here the test size. So let's say test size equal to 0.2, and giving here one random state. Let's say random state equal to, let's say, 42. Then we will assign it to the variable called xtrain comma xtest and ytrain comma ytest. Well, so we divide our data set in the train, test, and split. Yeah, now you can also checking the shape of that. Let's say xtrain ka shape. Yeah, this is the shape of the xtrain. Yeah, how the shape is look like. You can also checking the shape of the ytrain also. Let's say ytrain. So if you try checking this one, ytrain, then you can see the shape of the ytrain, how it will look like. And you can checking the shape of the ytest. Okay, and this is how the ytest shape look like. If I try to checking the xtest shape, this is how the xtest shape look like. Cool. Now what I can do is simply going to divide the data with the 255. So 255 is nothing but the highest value of the RGB images, because RGB images start from 0, I mean for the black pixel, and the greater one is the white pixel, and the white pixel is not but called the 255, the maximum value of the images. So for normalizing your data, it's called the normalization. So what I can do, you can divide your data with the 255, so that your data should be lie between 0 to 1. 0 to 1. So that's why divide your data with 255, the image data, the image data. So xtrain, so that your data should be normalized in the from the 0 to 1. That's a 255. Okay, this is called an scaling. You can also say the scaling or the normalizations. Okay, so going to copy this one and do the same thing for x test. Okay, for the x test. Now let's assign the variable called, let's say, xtrain call scale. Okay, and do the same thing for y test scale. Okay, you can also say the normalizations also. Let's say x test scale or scaling the value. Yeah, so it will dividing your data with the 255. Now your data should be lie between 0 to 1. Now you can simply going to passing your data in your deep learning or CNN model. Okay, your artificial intelligence, sorry, artificial neural network model. Yeah, so for this case, we're simply going to using here the convolutional neural network, and we're simply going to try to building it from the scales. Okay, you can also checking this one scale, how the data look like. Yeah, you can see the data is kind of converted into 0 to 1, 0 0.16, 0 0.12, 0 0.43, 0 0.69. It's not greater than 1. It's not greater than 1. You can also checking the shape of the your scale value. That's a shape. Okay, dot shape. Okay, so this is how your shape is look like. This is the images, this is your width, this is your height, this is your number of channel. If your data is not look like that, you have to reshape your data. You have to reshape your data, but in this case data is already reshaped. Reshaped means which kind of reshaped actually? In CNN, when you're passing your data inside your CNN, there should be the one thing for number of images, I mean total images, which are going to pass, then width, and the height, then the number of channels. This is how your data reshape actually look like when you're going to pass it. See, our data is already scaled and also reshaped for the CNN model. Now we can simply go into building here our CNN model, our deep learning model. Yeah, so now let's try to building here our convolution neural network model. So for that, I need to also import here. So let's first import here the TensorFlow. Let's say import TensorFlow STF. Then after that, I'm simply going to import here the sequential model from TensorFlow.keras.model. So let's say from TensorFlow.Keras.models. I'm going to importing here the sequential model. Okay. Then after that, from TensorFlow dot Keras dot layers, then I'm going to importing here the conv2d. Okay, conv2d. Okay. So you can also press the tab key from your keyboards for getting the auto suggestions. Then after that, I'm simply going to using here the max pooling 2D. So max pooling 2D, pooling 2D. Okay, fine. Then after that, I'm going to importing here the flatten layer. So let's say flatten, yeah. Then after that, the dance layer. So dance should be dance capital, okay, dance layer. Then I'm simply going to importing here the dropout, because dropout is needed just because of uh, deactivate some neuron while you are training the deep learning models. Then we can using here the dropout to deactivate some of the neurons, just like 20% neuron should be the dropout, while the backward propagation should be happening, right? So that's the library. I mean, that's the input is needed. So shift enter. Well, no error. Now what I can do is simply going to building here our CNN model. So we're going to be building one sequential model. That's mean passing the data from the one layer to another layer. That's the basic things behind the sequential layer. You can also using here the functional API to building your functional API based layer. Okay. So in this case, I'm just going to creating here the sequential layer. So let's say model equal to initialize here the sequential. Okay, sequential, and after that I'm simply going to adding one by one. Okay, so let's first add first layer. Let's say model dot add, and inside this add I am simply going to using here this conv2d. Okay, this convolution 2d. Okay, then after that I'm simply going to be giving here the number of parameters. So let's say 32, and I'm giving here the kernel size. So kernel should be the kernel size, kernel. Okay, kernel size. Let's giving here the kernel size is called 3 cross 3. Okay, just I'm going to giving here one filter of, or you can say kernel of 3 cross 3. That's mean 3 cross 3 is nothing but one matrix. It's by default initialized by our PC. Okay, 3 by 3. Okay, it's a kernel. Okay, now what I can do, I'm going to giving here my activations. So activations is nothing but, let's say, ReLU activation functions. Okay, ReLU activation functions you can use it here. Then after that I need to giving here my input shape, because this is the input layer. Okay, input shape. So my input shape is nothing but 128 comma 128 comma 3. If I see this one, that's called 128 128 3. That's mean number of width, number of height, and number of channels. I mean, if it is the image, right? Because convolution neural net actually work on the image data. It will try to get in the features from the each of the images and store it inside our model file. Well, now let's add here on max pooling layer. So let's say model dot add. Then I'm simply going to adding here one max pooling 2D layer with having the max pool size, the pool size of, let's say, 2 comma 2. Okay, the basics one, 2 comma 2. So 3 comma 3 means this is nothing but one matrix of 3 cross 3. 3 cross 3 matrix, 3 cross 3 matrix. Okay, 3 cross 3. Then we have the kernel of 32. Okay, that's our kernel size. So what I can do, we simply going to use this 3 cross 3 3 cross 3 matrix on the 32 cross 32 types of matrix, just like the convolution operations, then getting the features from our images. An image shape is nothing but 128 123. So that's mean 128 cross 128 cross 3 types of 3-dimensional matrix we have. Then we apply here 3 cross 3 matrix to getting the features. Well, fine. Now, okay, now let's add here the another layer. Let's say what I can do, I am simply going to copy this one. Then I'm simply going to using here the next one, that's called 64. Okay, with having the 64 filter. Okay, now inside this kernel size, should be the same, but just without having the input shape, without just having the input shape. Now let's add here one flatten layer. So flattens mean it's just going to convert this all the data in kind of a flattened vector, just in one vector. Let's say we have multi-dimensional array. So how are you going to pass in this data inside an CNN model? We need to pass in this data just like one vector. I mean, let's say we have a multi-dimensional array like that, 2, 2. Okay, let's say 3, 4. Let's say 5,6. Okay, and let's say this is multi-dimensional, so that's mean there is a two bracket. Okay, so let's say 1,2, and then this should, let's say 2,3. Okay, then let's have we have 4,5. So what it can do, flatten, the flatten is trying to convert them into one single vector. Let's say like that, 1, 2, 3, 4, 5. Like that, it will try to convert them into flattened vectors. Okay, so let's say let's add it here. So model dot add equal to flatten. Okay, flatten. Oh, थोड़ा mistake, मेरा कीबोर्ड में कुछ प्रॉब्लम वगैरह हो रहा है इसलिए. Okay, let's cut it down. I don't need it. Okay, flatten. Then after that, I'm simply going to adding here one dance layer. So let's say model dot. Okay, model dot. I think there should be also one brackets. That's why this kind of problem actually happening here. At yeah, here is also. Yeah, this is okay, this is okay, fine. Okay, model dot now we're simply going to adding here on dance layer. Okay, dance layer, and after that I'm simply going to giving the dance of this 128, also called the activation function. So let's say activation equal to ReLU activation functions. Okay, this is nothing but a fully connected neural network. Okay, now after that what I can do, we're simply going to add here one dropout. So let's say model dot add, and we simply add here one dropout, and 0.5, 50% of the neuron should be deactivated. Now the question is, sir, how can I actually writing this kind of code? 32, 64, 128, kernel size should be 3x3, activity should be ReLU. Yeah, I am just following on research paper, and based on the research paper, I am trying to building this kind of machine learning model, so a deep learning model, and try to start the features from my images. This is just I'm following the papers, and from the papers, they initialize the input shape should be the 123, and the kernel size should be the 3x3, and you need to adding here one max pooling, and after that you can add here the filter size is 64, and add the flatten, then dense layer, and after that you can 50% of the neuron should be deactivated. How in the backward propagation should be happening. Okay, how in the backward propagation should be happening. Now I'm simply going to adding here another layers. So let's say add here, I'm simply going to adding here just like 64. Okay, 64, and activation should be the ReLU, and dropout also should be the 0.5. Now let's add here the final layer, which one is called the output layer. So output layer is also be a dance layer. Okay, output layer also be a dance layer, and inside this dance layer I need to giving here number of classes. So our case number of classes is nothing but two number of classes. Then I need to adding here one activation functions. Now the question, what kind of activation function should I give here? Okay, because this is a binary classification task. So is there I give here the softmax or sigmoid? Just pause the video and comment that, or think this thing, which one should be here, sigmoid or the softmax? Yeah, I think you got it. It should be the sigmoid. Why? Because when you have the just two types of classes, just like a binary classifications, your activation function should be sigmoid. If you had a multi-class tax of classification types, okay, multi-classification tax, then you can add here the softmax. Fine. Now after that, what I can do, I'm simply going to run it here. Yeah, it's running, but before feeding with the data, you need to also compile it. So let's say model.compile. Okay, model.compile, and after that let's giving here the optimizers. Okay, optimizers. So let's giving here the optimizers called Adam optimizers. So there are so many optimizers are available, just like gradient descent, uniform, other things it having here. Okay, so let's giving here the loss. So loss should be the for based on the papers, they're actually using here the sparse categorical cross entropy. You can also using here the binary cross entropy also for the calculating the loss. Okay, yeah, you can add in here the binary cross entropy. Okay, cross entropy. Yeah, fine. Then for the matrix, okay, matrix, I am simply going to using here the accuracy matrix. Okay, accuracy matrix. Yeah, because for the peppers they're actually using here the sparse categorical cross entropy, so it's better I can using this one. But obviously you can also using the binary cross entropy, because it's just having the two number of classes. Yeah, let's see what kind of accuracy got. Then I have also the model based on the sparse categorical class entropy, then we can use it. Okay, so now what I can do, I'm simply going to training the model. So for that, let's say model dot feed. Okay, and I'm going to pass me my train data. So my train data is nothing but my trained scale. Okay, that's my trained scale. And also giving here my y train data, so that should be the y train. I have, so there's a y train, here we go. And I'm going to copy this one. And what I can do, I have to giving here the validation. Okay, validation split. Let's giving the validation split. Let's say 10% of the data should be the validation split. I mean, for 80% for the training, 20%, 10% for the testing, and 10% for the validations. Okay, so let's giving here the epochs. Okay, let's giving here the 5 epochs. Okay, let's store it inside the history so that we can plot the graph. Okay. Okay, so I hope so. The model training should be the completed and it will start soon. Okay, this is how it actually work. Let's see it will working or not. So also for the binary cross entropy, we got here some kind of error. It's called logits and the labels must have the same shape received, because this, see, one thing, just one thing. See, this is nothing but on a sparse matrix. Just mean we just having one images and we have the labels. That's mean our input shape and label is not matching. It's just like a sparse matrix. So that's why we'll be using here the sparse cross entropy. Okay, sparse categorical cross entropy. Otherwise, it will give me this kind of error called logits and the labels must have the same shape, receive blah blah like that. Okay, so that's why I need to convert them into the binary cross entropy to the sparse cross entropy. That's why they're actually using this sparse cross entropy in their research paper. Let's say sparse categorical cross entropy. Okay, and also this is not accuracy. There should be a double C right now for the updated version of TensorFlow. So I'm simply going to run it here. Now let's see it will still starting the epochs or not. Okay, I hope so. It will start this. Yeah, start this epoching. I mean, for the training period, sparse categorical cross entropy. Okay, that's fine. Yeah, it has started the training part right now, and you can see it will take hopes 30 minutes for complete the training period. Yeah, so I'll back after when the full training part is completed. Then I started recording again. Well, so our training part is completed. So right after 5 epochs, we got here 93% validation accuracy and 92% accuracy on this data set. Okay, so you can also increase your epoch size and you can start the training part and hope so you can get here 92 to, okay, again. Well, so our training part is completed. So right after the 5 epochs, we got here the validation accuracy is 93% and accuracy is 92%. If you increase the epoch size, hope so your accuracy also increases. Now what I can do, we simply going to evaluate our model for checking the loss and the accuracy. So let's say model dot evaluate. Okay, model dot evaluate. Okay, and inside this evaluate, we simply going to pass in here my x test data. Okay, x test data, so that should be x test scale and also y test data. So let's say you have one pre-trained model. I mean, you already trained it before. So for that, for checking the accuracy and the loss, you can using here the model dot evaluate. Okay, see here you can see the accuracy, but when you have the just same model, just like the model dot is5, you can get the accuracy. So for that, you need to evaluate your model on your testing data. So it will give me the loss and the accuracy. So accuracy, that's it. So if I'm trying to printing it out, the loss and the accuracy, they can also checking it. Okay, so for that I'm going to checking here the loss, and after that I'm simply going to printing here the accuracy. It's better you can giving here one text. So let's say loss uh, is, okay, like that. Then we can say the accuracy is, okay, let's say accuracy accuracy is, okay, like that. You can printing it and give here one comma and give here one comma on that. Yeah, now if I printing this one, accuracy is not defined. Yeah, that should be the accuracy. Okay, and now fine. Yeah, you can see here loss is 90% and accuracy is 92% on the testing data. Quite good. Now let's try to plotting here the graph. So for that, what I can do, I can using here plt.plot for plotting the accuracy curve based on the loss also. So what I can do, we can using here, let's say history. dot history. Okay, I mean in the history this variable have one method called history, and inside this history you can getting here the loss. First let's taking the loss, then let's giving here one label also. So let's say label equal to, let's say train loss, train underscore loss. Yeah, then let's copy this out and let's try to do the same thing for the validation loss, or make it, let's say bell loss, and this is the bell loss called validation loss. And then we can add here one legend so that we can plot here two plot. So legend, then simply going to using the pld.show. So this one showing me the plot for the loss, and let's try to do it for also the accuracy. So just making it accuracy, let's add double C and make it add double C. This is the training accuracy and this is the validation accuracy. Well, fine now. Yeah, you can see here the accuracy how these look like, and you can see the loss. So the loss is decreases and the accuracy is increases, and we don't see any gap here. I mean our model is really working fine. It don't have any overfitted or underfitted problems on the data sets. That's really cool. Now what I can do is simply going to save the model. Okay, that's a model dot save, and inside there let's giving here one name called model dot s5. Later on, we're going to using this model.as5 to building the web application in Flux. If I see this one, just to wait, you can see the model.as5 file here. Okay, well. Well, so right now we are trying to building the web applications using the Flux framework. And I'll do the coding part here, and you can see here app.py. So let's run the application, then you understand what actually happening inside that. And also you can see in this site, you can see here extra three folder, static, the template, and also the upload. So inside this static folder, it having the CSS and the JavaScript code. And also inside this template folder, it having the HTML code. And inside this upload folder, when I clicking this button called upload, it will storing these images inside this upload folder. Okay, so our application is up and running, and you can see here it will give here one link. So I'm simply going to follow the link. So also our application is loaded. If I click here to choose one images, and if I select here one images, let's say select this one, yeah, this one, and select click here to predict and see face with marks. This is how the application actually look like and how it actually work. See, this is one simple the neighbor, and this is one simple text, and this is simple one upload button, and this is the image view and the result. So let's see what actually happening inside this code. So I'm simply going to close it right now. And if I say inside my static, template folder, you can see here it having one import.html file, which having one title called advanced project, face mask classification using deep learning, and also having one static neighbor that you see in our UI called a class neighbor advanced project face mask classifications using deep learning. If I see this application again, and this is the neighbor advanced project face mask classification using deep learning. Well, and also you can see here neighbor is nothing but dark. Okay, bg is also dark, and neighbor is also dark. That you can see also here it's also dark. Okay, now if I go inside this index.html, see this is when block content and the and block. So inside this Jinja template, we're simply going to passing here our index.html file. Okay, now you can see here inside that we have a center tag, and after that you have the face mask classifications using deep learning. Then you have one simple beard tag. If I see that, here is it, face mask classification using deep learning and one beard tag. And after that we having the one form. Inside this form we have one upload file. Okay, id upload file, and method is post method. And when I click in this button, okay, it having one id called the image upload, and it will accept the png, jpg, and jpeg images, and name is nothing but file, and file type is also file. That means you can select only file types. Then it having one sections, and inside the sections you can preview the images. Then it having another loader sections. When the output is not coming up, okay, it will start, it will loading that. Okay, then you having one tag called result, and it having one id. Now inside this result tag, we simply going to printing here our result. Okay, now if I go inside this app.py, then you can see here we input here the OS, the numpy, the PLU, the CB2, the Flux, and from Flux we input here the Flux, the request, and also the render tablet. Then you have the secure file name, because it's simply going to upload the file inside this upload folder, and you see here the images we upload is already stored in my folder. Okay, So now what I can do, we're simply going to use the load model so that we can load the save model that you save it in our Jupyter notebook. Then after that, we're simply going to creating here an app, creating here the flux. And after that, we're going to printing here, just check this link, okay? So that it will open. Then see, you have one route. So just initial route, and method is nothing but a get. So when a user first time visiting this website or web page, it will showing this index.html, just showing this on without these applications. Okay. Now after that, when the user clicking the predict button, okay, it will go and call for the predict functions, the predict method. Okay. If I go inside that, if I go inside this, if I go inside this index.html, so if I clicking this predict, okay, this predict, the upload button, not predict button actually, it will go inside this upload file. Okay. If I go here, you can see predict. So when I click this predict button, it will storing the predict. It will try to go to the predict part. Okay. If I go inside here, then you can see button is predict. Okay. Okay, fine. Now, if you see that if inside this app.py, so we have one method called def upload. If the requested method is nothing but the post method, then we're taking the file from the index.html. If you see just to wait, you can see name equal to file. It will taking this file based on this name, and after that it will store it inside the app, and after that it will save this file inside this upload folder. Okay. Then what I can do after saving this file, we need to getting the file path, and we're simply going to pass in this file path inside this function called get results. See here we actually using here the OpenCV, but in our face mask classification project, we're simply going to using here the PILU library. So in this case, we're simply going to read it using the OpenCV. Then after that, we're simply going to convert them into the array with the RGB, because we're already converting this image into RGB format. Then we simply resize it 128. Then we convert them into the numpy.array. Then we're simply going to reshape it. Okay, we're simply going to reshape it. So further, you're going to using here the np.expand dimensions. Otherwise, you can also using here this kind of way. Let's say np.reshape, and after that, you can passing here your image. Then to giving here 1,128, 128, 3, like that. You can also using this one for reshaping. So for this case, and NumPy already have the expand dimension function. So that's why I'm simply going to using this one. And after that, simply going to using the modular predict and getting this maximum value from the list. Okay. So, and then after getting this value, we're simply going to pass it inside my get name result functions. Okay. So if the class name is equal to lizard, that means face with marks, otherwise face without marks. This is how our application actually look like and how it is actually work. So now let's run it again and try to checking this out. It is really working fine or not. Yeah, it's already running. Yeah, you can see here it having chose image functions. So let's choose one images from without marks, because we already testing here the with marks images. So let's select this one. Okay, and click on predict. Now you can see predict button is appeared. If I click the predict, it is loading, and you can see face without marks. So this is how the application is look like and how it is actually work. So that's it for today. Now hope you enjoy this tutorial, and make sure to subscribe to the channel, and don't forget to hit the bell icon, and I'll be back with the another tutorial. So till then, take care and bye bye.